Welcome back to Computer Science 50. This is the end of week 1. Only 11 weeks to go. So I was at this dinner last night with the School of Engineering and Applied Sciences, and it was this celebration of Dean Venke, who's been with the school for 10 years as dean and has grown the school from what was formerly the Division of Applied Sciences to the Division of Engineering and Applied Sciences to just this past year, the School of Engineering and Applied Sciences. And for those of you interested in this sort of world, computer science, engineering, or the related fields, it's actually kind of an exciting time to be at Harvard, because this establishment of the School of Engineering of Applied Sciences, which on a day-to-day basis probably really won't affect your lives since you're already part of Harvard College, Harvard University, Faculty of Arts and Sciences, and now some of you the School of Engineering and Applied Sciences, it does signify that Harvard is getting all the more serious about engineering, computer science, and the like. And I hope that before long, reactions that friends of mine, for instance, have had over the years, like, whoa, you went to Harvard to study computer science, will someday soon be a thing of the past. It's exciting, too, because a good number of you seem to have joined us this year. Last year, the course had 282 students. This year, we're up to 341, which is particularly exciting for us. And so we are up to the challenge with our staff of 50 plus here. A few announcements before we proceed. 0 new handouts today. Please remember to section on the course's website, right on the home page up top in yellow with a red link. Is there a place you can section by 5 p.m. today? We, the staff, will then sit down tonight. Tomorrow, request some additional rooms, and then by Saturday morning, you'll get an email in your inbox, if not earlier, telling you who your TF is and where your section will be. If you end up having conflicts unforeseen or have some concerns, please just reach out to Jansu, whose phone number and email address is on the course's website if you need to, for instance, shuffle sections. Scratch boards will be available for the Hacker Edition if you're still so inclined, right after class outside. If you're sort of on the fence about this, we certainly have more of these to go around. If you're sort of on the fence and want to try it out, but don't necessarily want to commit mentally to submitting the Hacker Edition, that's fine. Feel free, if we still have the boards, to grab one, fill out that form, and then if you decide this just isn't working out so well, I would like to fall back on the Standard Edition, that's totally fine. This week, as in any other week. Office hours will take place in 3 different locations on campus tomorrow, from 7 to 10 p.m. in 2 dining halls, Quincy Dining Hall and Cabot Dining Hall, as well as in, I think, the Hallworthy study room for those of you closer to the yard. Do feel free to bring your laptops, your scratch boards, your scratch projects, and generally your questions. Lunch with David will continue this Friday at 1:15 p.m. Go ahead and just email that address on the board, rsvp@cs50.net. It's meant, again, to be completely casual. We will then follow up with you by Friday morning as to where the location will be. And on this note of lunch with David, you're all very kind to address me as Professor Malin and such, Dr. Malin and such in emails and in person. David is perfectly okay. We can keep it casual here. With that said, problem set 1, as with future problem sets, will be released on the website by 7 p.m. this Friday, if you're sort of raring to go. And this one will focus on C. And we will have you either jump right onto cs50.net, instructions for which will be provided in the PDF itself, or we might have you use nice.fas for at least one problem set so as to acclimate to Harvard's environment first before we take you away onto our own. So with that said, a few pieces of data. Being computer scientists and being fans of asking you questions, I thought I'd give you a sense of where you 342, since I signed an ad form a moment ago, who you are. Sophomores have taken the lead yet again this semester. We have extension students as well as GSAS students, but it's pretty much a similar distribution to last year. It's perhaps maybe not surprising. I, too, dove into computer science, and this course specifically, sophomore year. So if your friends are freshmen and they feel they've missed the boat, so to speak, clearly not, if there's so many of you here as sophomores. As for houses, I'm not sure why this is really interesting, other than we can compute it, so I did. Yeah, Mather, of course, is the best, which is why it's in green. Leverett apparently is really into CS50, whereas Lowell apparently has better things to do. But otherwise, things are pretty evenly split. So this was an interesting statistic because we discussed it head on last week. So the distribution of males in the course this year is pretty much the same, an increase of 10. But what's particularly interesting and we're quite pleased with is that the female enrollment in the course has literally jumped 60%. Go girls. versus last year. So that's a significant spike that we're quite pleased with. So just to show you the before and after, this was the before chart from last week, and the blue is slowly catching up to the purple. So 38% of you are now females in computer science. So I'd wager that's a good thing. So one other note, not to bring things down to a lower note, there's this huge policy in the course's syllabus, which we do urge you and expect you to read in its entirety. The course takes this matter very seriously, particularly because there's so many students in the course, and particularly because this is the type of work where you really are sort of working on the same thing that someone else is. It's not so much like a humanities course where an essay is sort of your own and develops independent of someone else's work. You will certainly be tempted, you may be tempted at one point to say, ask your friend for a little more help than is due. But let me make clear here that there is absolutely a line between chatting and collaborating with friends verbally, asking them to help you tease apart some concept, or I don't quite understand like why I can't get a do while loop to work correctly. But there's then a line when it becomes, here, let me show you what I did, or here, why don't you take my code and build on it. And so these several paragraphs in the course's syllabus, which will be restated in every future problem set, make quite clear, we hope, where that line is. Just to hammer this point home, let me show you some numbers. I'm sure with PowerPoint I could have automated this. But 15 is the number of students that this course ad-boarded last year for what we felt were quite clear transgressions of the course's policies on academic honesty. In each of those 15 cases were there patterns or presumed patterns of behavior we thought unbecoming of a student in the course, and it was not something that we certainly took lightly. So let me please beseech you that it gives us no pleasure whatsoever to look for similarities, to look for statistically unlikely similarities, but we do, and we're quite good at it. Yes, we do have special software to help us with this, but ultimately it is human adjudication that addresses this matter. So please familiarize yourself with that, and if ever in doubt, certainly just strike up a chat as to what's appropriate. There's 50 of us, and certainly there's resources to whom you can turn. And I would, again, beseech you at some point, if you all of us have had this experience. You've got a ridiculous amount of work to do. The problem set deadline is the next day. There are at least two superior alternatives to asking for a little bit more help than you should from a friend. One, you have 9 late days to spend as extensions you can give yourself in this course. And you also are allowed to drop your lowest problem sets in the course. So please think of those as the ideal alternatives and not some other. So let me now lighten the mood with your stupid internet forward for the day. We, at the end of the semester, will of course be engaging in final projects. And whether you have an iPod Touch or an iPhone, a BlackBerry, or just a personal computer on which you'd like to develop a final project, you'll have a whole bunch of opportunities available to you. And even though we won't cover, for instance, iPhone software development in the course per se, toward course's end, we will have various seminars on how to do such and such. But frankly, at that point, having seen Scratch, C, PHP, SQL, JavaScript, you yourselves will sort of have the ability to bootstrap yourself to another environment, another language even altogether. But I thought we'd use that as our segue to today's stupid internet forward as to just what else you could do with, say, a brand new iPhone 3G.
Will it blend? That is the question. And here we are in front of the AT&T store. And I'm here to keep up with the latest technology. I'm here to pick up my iPhone 3G. And I'm not the only one. Yeah! Hey, can I see your iPhone?
No, you're gonna blend it.
Not me? Ah, this is great. I can't wait to get back to the office and try out my new phone. Got my new iPhone, so I'm not gonna need the old one anymore. So I'm going to blend it. The new one is so cool. It's so much faster. It's going to keep me more organized. With all this technology, I won't forget anything. Now I'm going to blend my old phone. I think I'm going to press the smoothie button. iPhone smoke. Don't breathe this. Wait a minute. This isn't iSmoke. This must be 3G smoke. I blended the wrong phone. Oh well, maybe I could put this on eBay. Ah! Can I see your new iPhone?
So that is not a joke. That is perhaps one of the most brilliant marketing campaigns for an as seen on TV device. You can buy that blender and blend a ridiculous number of things. Go to willitblend.com if you would like to procrastinate later tonight. So, without further ado, let us take a look back at where we were Monday. So we started talking on Monday about how you write programs, not in Scratch, but on actual hardware with actual servers in this language known as C. So the general process, recall, was you take some empty text file, use any text editor, you fill it with what looks like English but is really C syntax. You then compile that source code into what was called object code. So object code, which is the zeros and ones that a particular CPU and operating system understands, and then can you double click, or then can you actually write that program's name at the prompt and have it do something. So to recap, if I pull up a so-called terminal window, recall that what I have done here is SSH, used the secure shell protocol with this free program called PuTTY to connect, in this case, to nice.fas, which you may do for this first problem set and will ultimately do on CS50.net. I've used what command to get myself deeper and deeper into this apparent folder structure. All right, CD, softball questions so far. And now I'm at a prompt where I can do something like nano, say hello.c. Now I could go ahead and start commenting my code, but that's not really necessary for a quick and dirty example. But I am going to start typing what's called the main function. So there was some jargon we didn't use on Monday, but for now just accept as fact that you must, for instance, begin any program you write, say for problem set 1, with precisely the following: int main, int argc, comma, char star, argv, open bracket, close bracket, parenthesis, and then if we want to do something really simple, we can do something like printf oh hi class, and then if we want to be a little anal when it comes to aesthetics, we can put a new line in there, close the quotes. Again, I have syntax highlighting enabled, which makes things a little more clear to read on the screen, but there is one other thing I probably have to include up top here. In order to use printf, which is not a function, not a mini program that I myself wrote, because clearly it's not on the screen, but instead it's in a library, the standard IO library, in fact, what is it I need to include at the top of this file? Yeah, so like sharp include, and then the name of what's called a header file. So sharp include, and then the convention is between angled brackets. Anytime you're using a library that sort of comes with the compiler, comes with the system, do use angled brackets. But we'll later see in the course that you can actually use double quotes if you actually want to include code you yourself wrote, but in a separate file altogether. So I'm going to do standard io.h, again abbreviating most everything, and that is going to now teach GCC where effectively printf is. So if I didn't make any syntactic errors, I'm going to go ahead now and type gcc hello.c, and then if I want to control the name of the output file so that it's a little more interesting than a.out, I'll do -o, which is a switch, hello, hit enter, nothing seems to happen, but if I do an ls, there in green with the asterisk is my program, I can type hello, and fortunately it seems to have worked. Well, let's do something intentionally bad here, since this is not an uncommon thing to do, although perhaps not in the simplest of programs. Still looks pretty good, but it's clearly missing the semicolon that I've just deleted. Just to simulate the kinds of perhaps cryptic messages you'll see, I'm going to execute the same GCC command now, and then you get this kind of message. So error expected semicolon before squiggly brace. So that's not actually all that cryptic because it's kind of telling me where it is. But mind you, later in the semester as your code gets more complicated, whoops, what just happened here? Clearly user error. But what did I open by accident? Yeah, so I opened hello instead of hello.c. So what I'm really trying to do now is look at object code, zeros and ones. But Nano is a text editor, an ASCII editor. ASCII referring to this global standard for what numbers map to what letters, 65 to the letter A. So Nano is not meant to write binary, zeros and ones. So what it's trying to do actually is interpret the patterns of zeros and ones that are in that file called hello and presenting them as though they were ASCII, because Nano doesn't know what kind of file this is. It assumes that that I, the developer, am a little smarter than it. So I'm going to quit without changing anything. I'm going to go ahead now and open the correct file, hello.c, scroll down here and add back the semicolon, and of course, all will be well. So there are a couple other topics we introduced last time. We looked at the notion of variables and certainly arithmetic, which isn't terribly exciting. But what was interesting about variables, unlike in Scratch, is that we had to, quote unquote, declare them. And what did it mean to declare a variable exactly? What's involved in that? You have to state its type. So there's a whole bunch of types that we saw, like an int and a char. There was long longs apparently, and there's a few other data types. But you need to tell C, as well as other languages like it, though not Scratch, what piece of data you're going to store in that variable. And it was as simple, it seemed, as doing something like int space x semicolon. Or if you need a bunch of them, int space x comma y comma z comma w semicolon. And then you can have as many of those as you want. And in this case of last Monday, we just did simple arithmetic. So why don't we try to make things a little more interesting? Play along at home here if you would. You've got a blank space on your slides, if small. The simple task at hand is to, one, say hello to the person next to you. And in the next 120 seconds, write a program that does the following. Asks the user to input a temperature in Fahrenheit, and outputs to the screen the equivalent in Celsius. And for those of you who don't remember the formula, it's right up there. So again, you were going to tell the user, give me a number in Celsius, and then you're going to tell the user what that value is in Fahrenheit. And a simple mental exercise or paper pencil will suffice, and I will spur you along here. Last time we let it loop. Okay, so let's go ahead and fill in the blank. Mind you, perhaps the most astute know that you actually have kind of the answer key here, but that's meant as reference. So I'm going to wing it here, and I'm going to call this program.c. And let's see, I'll get us started because we already sort of spoiled the results before as to what you minimally need. So include standard io.h, int main, int argc, char star, argv, and lest you think we're doing you a disservice by not explaining these things, all will be revealed in more detail next week and beyond as to what that stuff is. All right, so easy one to bite off. I just need to tell the user to give me a value in Fahrenheit. What do I do? Yeah, so that's the easy part. So printf, give me a temp in Fahrenheit. Now I could do this. Maybe I could just put a space. I'll go with the space, but this is merely an aesthetic. All right, how do I actually now get that value in Fahrenheit from the user? So a lot of little murmurings, none of which I could hear. Yes? OK, so we could go with int f. Gets, and you'll hear me say, and any programmer really say gets for the equal sign, because we'll soon see that in C and other languages, if you actually want to say equals, you actually do equals equals. But when you want to assign something to something else, as in the case of a variable, you use a single equal sign. And yeah, we can use getInt, which doesn't come for free with C, but rather is part of the CS50 library, which means we do now need to go back up here and add CS50.h. And you'll see that when you have your accounts on FAS and on CS50.net, we will have pre-configured the machines in such a way that that file is just automatically found by GCC. But we'll also make this file and the equivalent .c file available soon on the course's website, and also talk about what's going on underneath the hood there, and make it available for download if you want to play in some machine other than these two. So that would seem to work, but let's push back. Can we do slightly better than this, just to be a little more versatile than using this particular assignment? What's an alternative that some of you might have done? Yeah, so we can use a float, only so that we can tolerate the specification of decimal points. So let's change this just because, but really is up to us. And there does exist, recall, get float, even though we've not really used all of those functions just yet. So ideally now we have that value. What do we want to go ahead and do next? So we want to print out the value. So printf, and now that's, what do I want to do here? So I kind of want to give the answer. So maybe I should do something temporarily. So let me go ahead and say float c for Celsius is going to equal what was the formula? So Celsius equals 5/9. Unfortunately, the arithmetic just kind of translates nicely. You do have to beware order of operation, so keeping the parentheses is probably a good thing. Times what? F, but it's lowercase f, so things are case sensitive, minus 32, semicolon. So not all that much magic there, but ideally that will now give me the Celsius value. Now how do I plug in the value c? So I can say something like, let me remind the user, well, let's say what this value is in c. So that's like what? What do I put here in the blank? So it's not going to be that c in Celsius, right? Because that's not going to quite work. That's literally going to print a c. What was the technique for inserting sort of a placeholder? Yeah, %f in the case of a float, though there are others. All right, so that's %f, but now I need to tell printf what to put there. And so the second and beyond arguments to printf are what variables or values you want to insert there. So in this case, I think it's just c. So let's go ahead, and if I didn't make any errors, let's go ahead and just run make program so that I don't have to bother specifying the name of the output file. OK, looks OK, cryptic there, but no error messages. And let's go ahead and run program. Give me a temperature in Fahrenheit. Well, I know that 212 maps to something predictable. Good? Kind of off. All right. So what's going on here? What's that? OK, interesting. So we have this subtle bug from last time, right, where 5 divided by 9 is going to be 0 plus some remainder. But of what data type are 5 and 9? Well, they're sort of assumed to be just integers because there's literally no decimal point there. And so GCC assumes that's an integer. So if you divide an int, we said on Monday, by another int, well, you pretty much lose everything after the decimal point. So if that's, a point something, what you're going to get is rather 0, and that's it. So how can we fix this? A few different ways, but we can be just maybe a little more clear. All right, let's get back a floating point value here. Let's recompile it. So I'm going to rerun make. Let's run program again with another known value. And OK, so that feels pretty right. Now we can try another one. OK, that's pretty good. And I don't really know any other mappings than that. So we can kind of call it a day. Now that's not necessarily the best practice when it comes to programming. And what you'll find is that the teaching fellows and I were very good, certainly, at finding what are called corner cases, things that you might not have heard of. For instance, what's going to happen with this program if someone types in the value -1? Well, maybe it'll break, maybe it'll work. What if someone tries to get a little nasty and inputs the value like not 4 billion, which we generally think of as one of the biggest numbers you can represent, at least with like a float or an int? What if they type in 5 billion? What's going to happen? And so these are the kinds of thoughts that you'll hopefully start to think about or start to trip over, because it's failure to think about those corner cases that ends up creating problems on your own machines because some programmer at Microsoft, Apple, or elsewhere similarly just didn't think that that kind of input might happen. Well, let's see what happens if I don't actually give this program a actual floating point value or integer. Well, what if I say, hello, world? Well, one of the things that CS50's library does is try to save you the hassle of computing with data that's not of the type that you want. So what we have in the library is a loop, really, that's going to check if the user did not actually type a floating point, just keep prompting them ad nauseum until they actually say something like 212.00, which is, in fact, OK. Now, this is kind of ugly, right? Do I really need 6 degrees of precision when it comes to knowing the current temperature? Probably not. So let's clean this up. I don't necessarily want to lose all precision, but suppose I only want to see 1 decimal place. So something dot something. What was the tweak that we proposed on Monday for this so-called format string? Yeah, so between the percent sign and the F, you just do a point, and then you specify how many things do you want after the decimal point. In this case, 1. Let's try and recompile that. Let's go ahead and now rerun program with 212.0000, just to be difficult on the input. But it seems that it, in fact, likes that. So we could refine this further still. It's not a terribly sexy program, and so we'd rather not, we wouldn't really be impressing ourselves by refining it further. But let's do one other thing, which is to sort of remind the user what it is they typed in. So rather than ambiguously saying that's such and such in Celsius, what if we wanted to say this in Fahrenheit is this in Celsius? Well, how do I fill in this blank here? You can kind of stack these things. So just do another one here. And just to be clean, I'm going to do the same formatting convention. But now I have to insert that, and order is obviously going to matter. So I want Fahrenheit first, followed by Celsius. So again, you can have sort of an infinite list, or a finite but long list, of comma-separated variables as the arguments there. Let's rebuild that, rerun program, re-input, say, 212.0000. And in fact, now it reminds the user of what it was. So we can get fancier still. But again, at the end of the day, we're not doing anything more than converting one temperature to another. But any questions on some of the building blocks in that program? Yeah?
When you specify number of significant digits, is it round or truncate?
It's a good question. When you specify number of significant digits, printf, I believe, rounds. So it doesn't just chop it off, but it will round to the closest possible value. And in fact, we'll trip over this later. Remember from Monday that how many bits are used to represent a float underneath the hood? So 32 bits. Now, we already know that with 32 bits for an int, you can represent numbers like 0 up to 4 billion. Or if you care about negative numbers, maybe negative 2 billion to positive 2 billion. Right? You got to spend those bits somewhere. But when it comes to floating point values, 32 bits doesn't really give you as much expressiveness, it seems. Because suppose you wanted to represent a number like 2 billion point something, 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 like something really precise, but that's simultaneously really big. You're kind of going to have to give up one or the other, either the ability to represent a number that big or to represent a number that precise. Because if you only have finitely many bits, I mean, just intuitively, there's only so many points after the decimal place that you can remember. And so there's this interesting subtlety and bugs that can arise if you start relying on floating point values in some computer program, because the fact of the matter is there is an infinite number of real numbers. Right? That might have seemed unimpressive in grade school when you were told it. But now, when you only have a finite amount of memory, but you want to implement, say, a calculator that can compute any possible values, you kind of got a problem, because you can't express those values. And certainly in the real world, you've tripped over this in high school with your calculators. They can only fit so many digits. Well, the idea is pretty much the same in the computer. There's got to be rounding or some loss of precision potentially. But we'll see more on that as we proceed. So there's these other constructs we saw in Scratch. So there was this notion of conditions. And we teased you with this snippet last week at the end of our Scratch discussion. If you want to use a condition in C, it's literally as simple as if, and then parenthetically, some Boolean expression. And the definition in layman's terms of a Boolean expression is something that's either what? True or false. That's it. And what was neat, and we even saw this in Scratch, is that you can combine one Boolean expression with another to require, say, that not one thing be true, but that 2 things, or 3 things, or 4 things be true. You can get more sophisticated still and say, I want this to be true, but this to be false. That is, you can take sort of the conjunction of these different Boolean expressions and make many different requirements. So even though this is sort of the canonical form, know that where it says condition there, can you actually insert multiple conditions, as we'll see. But you can also branch. You don't have to just do something or nothing at all. You can also go this way or that way. And so in this case, you have this notion of an if-else construct. Notice what's interesting here is that parenthetically, we have the condition, but then we also have these curly braces. Because just like Scratch, whereby its if blocks kind of grow to fit however many puzzle pieces you want to put in, this is sort of the equivalent in C. So long as you put a curly brace that opens the block and a curly brace that closes it, you can put as many statements, as many other conditions inside that block as you want. But there's going to be some interesting implications of sort of encapsulating statements within these blocks that we'll soon see. Similarly for the else. Though there is one caveat. If you only want to do one thing, if something's true, else you want to do just one thing, that is where I have these comments, do this or do that. If you only have one statement to go there, you don't need these curly braces. So it's really an aesthetic thing, if anything, in that case. But we'll see an example. So let's take a look, in fact, at conditions1.c. So this is among your printouts if you'd like it for reference. But notice this is just a simple, trivial little program that demonstrates now slightly more interesting syntax. So this program, maybe without reading the comments, if you can avoid tempting yourself, but just look at the code at the bottom, what does this do? Here, if it hasn't spoiled it already, that's the delete command in Vim. What does it do? So the first line, obviously, just tells the user something. But then we're using the CS50's library to get an int. And then what are we doing now that's potentially buggy? Let's make it a little more interesting. What's the bug? Yeah. Yeah, so we're not handling the case of 0. Either I'm saying if n is greater than 0, tell the user you picked a positive number, and that seems legit. Else, tell them they picked a negative number, but subtlety of the positive and negative numbers is that 0 is neither positive nor negative. So that's not really quite accurate. So how can we go about fixing this? Well, first take note, I didn't bother with the curly braces, but this would be equivalent. Although this would now be inconsistent. So one of the themes we'll also begin to discuss more, both in lectures and sections, is this matter of style. Generally doing something like this, which is flat out inconsistent, is sort of considered, you know, almost in a religious sense, bad style. And so we'd want to at least be consistent there. But we don't need it in either place. But conventions you'll also see is that people don't necessarily put their curly braces in the same place. So this is another very popular, if not more popular convention. I tend to take the former approach just because it makes more obvious to me what belongs where. But the rule of thumb generally in the course, and we'll offer more tidbits like these, is that so long as you're consistent, you can sort of go with whatever style you find prettiest. But again, so long as you adhere to it. And as code gets more complicated and longer, these kinds of sort of rules of thumb are hugely helpful when it comes to reading your own code and giving it to someone else to actually parse. So let's go back to the version without these curly braces, because in this case they have no effect. But how do I fix this? How do I fix this bug? Someone else. Yeah? Yeah, exactly. So we can just embed another such thing and just not just say else, but else if n equals 0. We can go ahead and say, and I'm going to do a little copy paste job to save time, you picked 0. Yeah? Well, let's try this. All right, so this is conditions1.c. This is obviously a leading question. So let's go ahead and make conditions1. Interesting. Suggests parentheses around assignment used as truth value. So that looks mildly suspicious, but I don't really understand it. Plus, it's a warning. So GCC, like other compilers, will make this distinction. An error is a showstopper. Like, it's not going to let you finish compiling the code. A warning is sort of someone maybe more advanced than you's hint that this doesn't look really right. The odds are you screwed something up. I, sort of being a little more arrogant than that, I'm going to assume, I know better. Let's go ahead and run this program now. So this thing is called conditions1. I'm going to run it at the prompt. I'd like an integer, please. Let's give it 5. Picked a positive number. Let's give it -2. Picked a negative number. Let's give it 0. Ooh. I thought I just fixed this. So what's the problem? So right, double equals. Because what is this really saying? And this is why both exist. The equal sign is the assignment operator, which says put whatever's on the right inside the value or the variable on the left. So in this case, what that has the accident of saying, well, if n is greater than 0, go ahead and print this. But if it's not greater than 0, that is, suppose I literally type in 0, well, then this branch becomes applicable. So this branch then executes. Else if n gets 0. So what that line is doing is it's not only operating as a Boolean expression per se, it's sort of simultaneously assigning the number 0 to the variable n. So if at the end of that sequence of steps the value stored in n is now 0. Well, 0 is synonymous with the light bulb being off or with the Boolean value false. So no matter what now with this branch, if we reach it, this is saying else if 0 or else if false. And that's sort of a vacuous statement because it can't be true in that case. So that branch never leads to anywhere. And so the last possible branch is the only one that applies. And what it was warning me about is that because I'm nesting a statement, an assignment operation, inside of a Boolean expression, that is sort of by nature ambiguous. What it was hinting at is, if you're going to do that, at least be explicit about it. So I don't think you're doing something wrong. And if I go ahead and recompile this, let me remove conditions 1. Save the file, remake it. So now the error went away, the warning went away. But if I run conditions 1 and type in 0 again, it's still buggy. All I did was make the little voice go away. So the solution here is, again, not to parenthesize it, but to actually correct the logic of that particular error. So subtle bug, but mark our words, of the 342 of you, at least one of you will make that stupid mistake at 2 a.m. and waste 20 plus minutes of your life, because we've all done it. That actually doesn't really make you want to take a course like this, does it? All right. So you can do more canonically this kind of approach too, which is an if-else-if approach. But let's see what else we can do. So I said before, you can take not only the conjunction, but you can also sort of or statements together. You can say, if this is true or this is true, and we saw this in Scratch, do this, else do that. And clearly, presumably, can you nest these things again and again and again? Well, let's take a look at an example. This time, we're going to use the Boolean AND operation. So here, too, there's a distinction. If you just use one ampersand, that's what's called a bitwise operator. And it's going to do some fancy stuff on the bit level, manipulating individual bits, which is useful, but in this case, inapplicable. When you use and, ampersand, ampersand, that's saying and these things together. Make sure left-hand expression is true and right-hand. So let's actually see these in action. So in this file called nonswitch.c, first we have some comments. Let me get rid of my own comments in the middle. So here's our program. It says, give me an integer between 1 and 10, then get an int, store it in n. And what is the effect of this program now? It's kind of contrived, but it's a little more interesting than the last because it's not sort of this ternary type answer. We're actually using ranges here. So what's this going to do? Just in layman's terms, it's a stupid program. Right, I wrote it. I know. Right, so if you enter a small number, which I arbitrarily said is some number between 1 and 3, it's going to say, hey, you picked a small number. If it was between 4 and 6 inclusive, it's a medium number. 7 and 10, it's a big number. And then if it's anything else, I decided just because it's not a valid number whatsoever. But the interesting pieces of syntax, or little things to tuck away in your mind, are that there is no sort of greater than or equal to symbol on the keyboard. But there is a greater than symbol, and there is an equal symbol. And so in C and other languages, you simply do one after the other to say greater than or equal to in this case. And if you just wanted greater than, could I do this? In fact, if we really want to do some sort of trivia here, if I didn't remember that this operator existed, it's kind of really a bad day. I mean, this would be equivalent to what? Greater than 0. That kind of works too, right? Because it's an integer, there's no decimal points, and the only number greater than 0 that's an int is 1. So that has the effect of saying greater than or equal to 1. But I chose this approach. Let's go ahead and just run it to see what happens. So make nonswitch.c. Whoops, make nonswitch is the convention with make. All right, now I'm going to run nonswitch, run enter, give me an integer, 11. I picked an invalid number. How about -1? No, how about foo? And now we get my own retry mechanism. And you'll see, too, people like us in the front of the room here use words like foo, bar, baz, quux, and a whole bunch of other random words that actually have some historical meaning. Turn to Wikipedia for this. But these are sort of computer scientists' variables. An algebra person likes to say x, y, z. We like to say foo, bar, and baz, and it will grow on you. So what else can we do here? Switches. So there's this other construct altogether, which is different, certainly aesthetically, from anything we saw in Scratch. But it allows you to handle this case where you start to have lots and lots of conditions. Because one of the rules of thumb you'll sort of develop when it comes to style is if your code starts to get really really wide. Like there's a lot of indentation. You have an if nested in an if, nested in an if. And literally your code can't print on a piece of paper without looking hideous because it just wraps. Well, that's sort of a problem of style. And so there exist other constructs that functionally don't empower you to do anything more than you could previously, but they allow you to do things in different ways. And so a switch is sometimes in order, and we offer the syntax in this example. So switch1.c is again going to assess sort of the magnitude of a user's input, but it does it very differently. And this approach is maybe better for one reason, maybe worse for another. We'll see if we can offer one or two examples, but it does the same thing. So the syntax here is that I still have my main function. And to be clear, if you haven't sort of inferred already, every program in C starts with the main routine. That is the function that gets called when you just type a program's name at the prompt. All right, so this thing's going to ask the user, give me an integer between 1 and 10, stores the value in n, just like before. And now we have this switch construct. So literally the keyword switch, and then parenthetically you specify what variable do you want to switch on the value of. Which one do you want to check again and again? And you can kind of infer probably how this is working. The way the switch statement works is you can have any number of cases where you literally say case and then the value you care about, colon. Case, the value you care about, colon. And you can stack these things. And you actually don't even need the white space, although arguably it's a little more readable as it was. But this too is a little cleaner because it takes up less space. So again, it's sort of a stylistic trade-off. Well, what that means is that if n is 1 or n is 2 or n is 3, do the following and keep doing the following until you see what keyword break. So this allows you to nest embed multiple statements again and again and again within the same branch, so to speak, and you only break out of this whole switch statement when you hit literally the keyword break. So what this is saying is identical to the previous example. If n is greater than or equal to 1 and less than or equal to 3, print this is a small number. But this is simply a different way of doing it. But what's at least interesting is that down here with default, this, as you might imagine, is just the case that applies just like an else statement would. And OK, so who cares? This is maybe better, maybe worse. Why is it better, perhaps, than the previous version, would you say? Completely subjective here. You can sort of read it faster, right? Literally just skim it from top to bottom. And it's pretty clear what the breakdowns of small, medium, and large numbers are. What's bad about it, perhaps? What don't you like? So it's what? So it's longer, right? It barely fits on the screen, and this isn't even that much code. So maybe a trade-off there. So again, this is one of the things that you'll sort of learn by example or just develop your own strong opinions about for whatever that's worth. But you have these options. But I will say that there's some cases in which, no pun intended, that this is sort of preferred, especially in the case of writing a program that maybe takes commands, like a game that you either want to hit up, down, left, or right, where there's sort of conceptually these different operations you want to apply that themselves might have a whole bunch of functions or statements involved with them. Well, you might sort of implement that game's primary user interface, the thing that just keeps listening constantly for commands, with something like this, partly because it's so readable and it's very clear as to what code is doing what. Shuttle Boy, for instance, has a big switch like this to handle literally up, down, left, right, and some other hidden keystrokes as well, just because it's cleaner to read than a whole big if statement. Well, what about this example, though? Switch2.c. So notice that even though we've been focusing on numbers, you can do slightly more interesting things. In this case, I'm sort of assessing a student's grade. So I'm arbitrarily saying that an A, maybe uppercase, maybe lowercase, whatever, is going to be an excellent grade. A B is a good grade, and so forth. Well, in this case, clearly we're switching not on an int, but on a char. And I know that because C, which is in the parentheses next to the switch statement, was defined 2 lines earlier as a char. But this probably shouldn't surprise you. Why is it sort of uninteresting that this also works for chars? Like, why is this, in fact, this should be obvious. Why? Right, a char is just a number, right? In fact, if I'm checking for the value A, I might as well, capital A, I might as well just be saying if C equals what? 65. But humans sort of prefer to think sort of in numbers here, plus in letters here. Plus, if the world, for whatever reason, decides to change the encoding scheme, as has begun to happen at least with different characters, not the these base letters. If you've heard of Unicode, this is another scheme that's used these days to express more than just English spoken characters. And Asian languages that have many more symbols than, say, 26, for which you need more bits. Well, this is to say you're sort of future-proofing your code if at least you don't hard code what might be called magic numbers. Numbers that do have some meaning, but they make certain assumptions, or that's not obvious what they mean. So just use the chars in this case. But unfortunately, the buck kind of stops there. There's a couple other cases in which this works, but you couldn't, for instance, do something like this. String s gets get string. What you can't do, we'll see, is say something like this, and then say something like this, because the language is not as so sophisticated as to compare multiple characters one after the other. So we'll have to come up with another approach altogether for this thing in time. All right, well, what about loops? Because once we can do something once, we might want to do it again, especially since that tends to make programs more interesting if we induce loops intentionally. Well, what about this example here? So this is just a snippet of code that depicts how you can go about implementing a loop. And there's different approaches you can take to a loop. There's this while loop, just like Scratch had a couple different approaches. So suppose my goal is to open up this program here, progress1.c. So notice, whoops, I skipped one slide. It doesn't matter which order we do it in. So there's two types of loops in the world, at least. So there's the while loop, which you just saw. And before that, there was the for loop. So the for loop is actually the slightly more complicated of the two. So let's actually start with that. And then the while loop will seem terribly easy. A for loop looks like this. And this might look a little cryptic, but all this is saying is that there is sort of a structure in place when you want to do something again and again and again to tell the language C to first initialize 0 or more variables to some values. Like that, like a counter, 0, 1, 2. That might be a useful thing if you're trying to iterate. There's a condition that you can tell the loop to check constantly, similar to Scratch when it was like loop until such and such. Well, you can say keep repeating until this condition is false. So it's kind of like having an embedded if statement. And then you can have updates, right? Because the idea of iteration, if you want to keep track of how many times you've done something again and again, you might very well want to stop at some point. So if you're counting, you're going to need to increment plus plus, plus plus, plus plus. And so there's a place for that kind of statement to go. So in progress1.c, we have this. So this is a very specific instance of a for loop. We have a for loop that literally starts with for. There's nothing else going on. Notice that I've sort of inlined the declaration of a variable. I could have put it up here, but if I'm only need it inside this loop, I might as well just define it within the so-called initializations area. Well, what do I want to do? Well, first initialize I to 0. Because programmers tend to count from 0, though I could do it with 1 and it'd be no different functionally. Do the following while I is less than or equal to 100. So I want to iterate 100 times, it seems. Or rather, maybe even a little more. How many times is this loop going to iterate? So it's actually 101, which again is one of these subtleties that if you're not quite sure what your code is doing wrong early on, sort of in week 2 of a course like this, look for the stupid things, like I used less than or equals instead of less than. Well, what do I want to do after each iteration of this loop? Well, I++, just add its value up. And so the effect of this loop, sort of cryptic as it is, at the end of the day, just means initialize a variable to 0, and then keep counting all the way up to 100, and once you hit 100, stop whatever it is you're doing. Well, what are we doing? Well, this is a little new here, this line. We're going to print %complete, but let's try to infer what this is doing. So %d just inserts what? A decimal, a digit, like an integer, all right? But then there's this funky thing, %%. Yeah, so we've not seen this before, but remember like the \\/ question from Monday? It's the same idea here. If you have some symbol like a % sign that has special meaning, but you kind of want to show that same symbol on the screen, well, %% means show us 1% symbol. And then the \n, of course, is the escape character for the new line. And then sleep. I mean, take a guess what this does. It puts the program to sleep for, in this case, 1 second. So this actually hints at this notion of threading. What this probably has the effect of doing with this program is not just sort of locking your computer for a second, whereby you can't do anything, but rather literally puts the thread, the sort of piece of the resources devoted to the execution of this program, to sleep for just a second so that the computer can go do something else. And then 1 second later, does this thing wake up, print again, and go back to sleep. So let's run this. So GCC, just to show you again the other syntax, but it's the same thing. Progress1.c, we'll call the name progress1. Oh, OK. So interesting little gotcha. So if you see a message like this, it means that, one, you, like me, forgot how we've configured the server. So this is why eventually in the course we'll get into the habit of running make. So make, again, automates the sequence of commands you need to type. And if you recall, one of the things it outputs in this case is this line here. Dash standard equals C99. What that's just telling GCC is assume the programmer's using the newer version of the language C, the 1999 version. But because I didn't type it at the prompt, it assumed I was doing it the old school way, which doesn't allow you to put things like integers, declarations, inside of any block of code other than the very top of the function. So with that said, let's run this thing. So program 1, it's not even going to take any progress 1. It's not going to take any user input. But it's kind of neat, in that now we kind of have animation. Right? So now we're doing something a little more interesting than this basic input-output thing. Should we watch it? Go? No? All right. So Control-C is the way to break out of a program that's running generally. Or if you just want to kind of pause it momentarily, incidentally. So let me start this over. Control-Z will generally suspend a program, which is similar in spirit to making it go to sleep. But this now means it's literally not just sleeping and waiting to it's sleeping in the sense that now it's waiting to be awoken by me manually, as opposed to something happening automatically. Now I can go about doing anything I want. And then when I'm finally ready, I can type FG for foreground. Yeah, and unfortunately, it didn't make any progress while it was suspended. So Control-C gets me out of this. But let's take a look at a slightly more interesting version. Progress2.c now does something slightly differently. All right, so point out what's different here. There's some slightly new syntax. So there's this \r, which we didn't address head-on Monday, but it was on that slide. What's a \r? So this is what's called a carriage return. So back in the day, and I guess even I kind of had a typewriter growing up. Back in the day, there was like one of those levers on a typewriter that when you pulled it, not only moved the paper up one line so that you could start typing on another, it also returned the carriage to the left-hand side so that when you typed your next word, it was not only on the next line, but it was also all the way back on the left. So computers similarly have this notion, and Windows and DOS tend to use this even more than Unix and Linux. Not only can you tell the computer to go from one line to another with \n, you can also say go to the start of the same line with just a \r, a so-called carriage return. And there's this nuisance in the world of Windows versus Unix and Linux whereby the Windows world, Microsoft years ago, decided we are going to represent the notion of a new line with \r\n. So that is the two characters that always appear at the end of a line in any text file in, say, DOS or Windows. The Linux and Unix people decided \n is enough. So we're not going to have this \r at all. So I mention this now only because when you start uploading files from, say, your computers to CS50.net or FAS, whether it's web pages or C source code, you'll sometimes see garbage characters appear on the screen. You'll literally see like a caret symbol, the upward arrow, and then a capital M, which shouldn't be there. And what that is something like Nano's depiction of this weird \r, which in the world of Linux shouldn't really be there. So random aside, but because you'll likely see something like that, but we'll point out ways to get around it. So yes, \r is in fact going to get printed, but there's no \n. So can you describe for me what this program will probably look like when run? Say again?
Like one on the right and then two to the left of it, and they keep sliding forward.
So close. So there is this sort of sliding back to the left. But because the words that I'm printing are again and again and again the same, and because the \r itself is not a viewable character, so yes, it's taking up on my screen 2 places on the screen, but it won't print to the screen per se. It will just move the cursor to the left. Literally, the PERCENT ... will just keep getting reprinted again and again and again on the same line all the way at the left. But what will be changing each time is going to be the number. So we have this sort of faux implementation of a progress bar that's certainly a little nicer than the one I just made, because at least now you get sort of this effect. So this is perhaps a rare use of \r. It's not something you'd use commonly, but what this does hint at, and as we'll see in probably at least one problem set, is that even though a lot of the programs we've been running aren't terribly interactive, and the programs we've been writing certainly haven't been more interactive than typing some input at the keyboard, well, we will get to at least one point where you write perhaps a game that actually has on-screen animation. So primitive though this interface seems, you can begin to do more interesting things than this. But I'll move us on rather than wait till we hit 100% there. So can we do it any differently? Well, there is this other approach. And this too, like the switch statement, doesn't empower you to do anything that you couldn't already do, but it perhaps lets you think about the problem in a different way. And as programs get more sophisticated, the ability to express yourself, you know, like in English, in multiple ways can sometimes lend itself to greater clarity when it comes to you or someone else reading your code, or just it's simpler to express yourself with one construct, like a while loop, versus a for loop. So for instance, this program here has a variable declared at the top. Int I gets 0. So I'm sort of pre-declaring my variable and initializing it in the same statement. Now below I have this comment, and incidentally this was my own fault. You can use, as we've said, both /*/ to demark multi-line comments, but generally the convention these days for single-line comments is just to do a // at the beginning. So that was a remnant from last year's convention. So this year we've taken this approach. So now the while loop. So it's kind of straightforward, right? While the variable I is less than equal to 100, print the same stuff as before. Then this flush thing, which we'll come back to, sleep for a second. But now I kind of have to manually induce the incrementation myself. And we've seen that before. It's not all that hard, but I have to specify it. So the for loop kind of does that for me. It just puts that in a different place. But functionally, these are equivalent. So why might we have this thing here? flush. So file flush is what it's referring to. But any idea, and it'd be a stretch to know this off the top of your head, why do I have this line here? Because in the context of \r. Yeah. No. So flush. Why might what is there to flush here? Well, what's yeah. Sorry? Get to the previous number? Oh, get rid of the previous number. Not quite, but that's not a bad guess. So it does not have the effect of just clearing the screen or something like that. But what's really going on, and we'll get to another conjecture?
I'm not sure, but maybe printf prints to a temporary buffer rather than actually printing to.
Yes, so this is actually the explanation. We'll see more examples of this notion. But for efficiency, what computers tend to do is they buffer either input or output. So think of it even in the real world context. Sometimes you might be a little impatient and you double click some program and then you immediately start typing. And you just want Microsoft Word or AIM or whatever to just deal with the fact that you're typing. And as soon as the window appears, just dump out what it is I was typing while you were loading. So we've all probably kind of been that impatient. And the fact that that works is because operating systems like Windows and Mac OS have buffers for things like keyboard input or even mouse movements or output to the screen, so that even though the computer might appear to be doing something else, like launching that word processing program, well, there's no reason that with another thread or another CPU or another core, it can't simultaneously be logging, albeit temporarily, what you're typing. And it's logging this to a chunk of memory, which just generically is called a buffer. And so similarly, when a computer, for efficiency's sake, doesn't want to go through the trouble of printing every damn character one after the other, because there is a cost to that in making the computer do things sort of piecemeal instead of in bulk, well, it will try to just buffer up characters. And typically, a program written in C will only display something that you've printed with printf once it sees a \n. That's not always the case. But in this case, where I'm not using \n at all, the computer, just because it's lazy and is trying to be efficient, might not ever print anything to the screen or might not print my updates unless I explicitly say, flush whatever it is I put in your buffer now. Don't wait until a new line comes along, because I, the programmer, am smarter than that because I know it's never going to come along. So here too, computers can only do what they're told. They can't simply know or guess. So this has the effect of saying everything I just put into the screen buffer, flush it, dump it out. So it doesn't mean get rid of it, but it means dump it out and prepare for some new input. So any questions about for loops or while loops? Yeah.
So if we have the number going down, we could just overwrite so that last digit actually left like numbers without one.
Oh, good question. All right, so what if we were counting down? Is there going to be an aesthetic bug? Is I think what you were hinting at. So let's try that. So let's initialize I to 100. And let's go ahead and then change this to be, well, not that probably, but I is greater than or equal to 0, perhaps. And then this thing changes to what? Just minus minus. OK, so I've kind of flipped the program around just by changing it in some key points. So and if I really wanted to be anal, from 100% to 0%. All right, so let's go ahead and make progress. And incidentally, I'm hitting Control L every time to clear the screen, and that's just so that it's hopefully easier to see, so it's not behind my head. So Control L clears the screen. Progress 3. Let's run progress 3 at the top of the screen. So my cursor's kind of in the way, but there is in fact a bug. Right now I have a double %. But it's not because I'm printing 2% signs again and again. It's because I printed a % sign the first iteration that just so happened to be over here. But because every number less than 100 only takes 2, maybe even 1 place, you sort of have these remnants on the screen. So how could we fix this? All right, so we could take the arguably slightly hackish approach of like this, right? And just make sure we're going to overwrite it. Let me remake that. Let me rerun progress 3. Oh, much better. But now this sort of cursor's in no man's land, and an astute TF would say, come on, this you can do better than this. So what could we do here? Well, can we do something like, what about something like this? I don't want decimal points, but I do care about the width. And we didn't look at this Monday, but there was the notion with printf format strings of both width, like how much space should you reserve for this thing, versus precision, which is how many numbers should you show after a decimal point. What if I sort of experiment with this idea? %3d, and then this fanciness here is, again, just to print an explicit % sign. So let's remake this, rerun that. Ooh. So that, I still have the green cursor in the way, and it's hard to get rid of that unless you use more sophisticated libraries, so to speak. But that's arguably better, because what's this telling printf to do? It's saying no matter how big in terms of magnitude that number is, always use 3 placeholders for it, and just pad the rest of the space with white space. If you want to see this more clearly, let's say 13 instead of 3. Remake it, rerun it. Now it's way over there, but notice what this implies. This means you can kind of format your data, albeit text data, in rows and columns and whatnot, by sort of reserving some number of spaces by just using these format strings. So that was a perfect question to sort of lead us down that road. Other questions? Yeah? What if the number is, so good question. If the number now is longer than the amount of space you have, you kind of have to deal with it in other ways. Either it's going to wrap, or in some windows it just won't be seen. So you have to have some sort of foreknowledge of the maximum range of values allowed so that you can actually handle that. So for instance, Shuttleboy, the old Unix version, what I do is I actually check how wide is the user's window. If their window is not like 76 or 80 characters wide, just don't let them run Shuttleboy at all. Maybe it's a little heavy-handed, but it allowed me to make then certain assumptions about what would fit on the screen. I mean, websites do this today too, right? Most websites assume that your window is at least 800 by 600 pixels wide. Or now Facebook, one of the new enhancements to the oft-discussed Facebook revisions is now it's actually wider than the previous version, because now Facebook is making assumptions that most people, or at least their clientele, have monitors that are at least 1024 by 768 pixels, which is actually one of those sectioning questions. I mean, we're actually asking that partly because we're curious as to how much stuff we on the courses website can fit on your screens for similar reasons. So there's yet one more construct that allows you to loop over something again and again. And this is the do-while construct. And this one is perhaps less obvious in terms of its usage, but it does have applicability when you're trying to do something at least once and maybe again and again. So I would say most of the time, at least I in life, have always used do for loops and while loops, partly for stylistic reasons, choosing one or the other, or because it just made more sense logically. Do while is I find it most useful, if rarely, in the case of writing like a game or a user interface, where you want to tell the user something and make them do something, but if they try to mess around and don't provide, say, a legit value, you want to do the thing again and again. So in cases where you want the user to do something, but then do it again and again while some statement is true, like they screwed up, they screwed up, they screwed up, a do while construct might come into play. So let's take a look at this. So in +1.c, we have this example here. So loop until user provides a positive integer. So this is the same idea as before, just getting input from the user. But now I've nested it in a loop, because what I want this program to do, literally, is the following. Tell the user something, get a number. But if they're not satisfying my expectations, namely they're not giving me a positive integer, that is n is less than 1, well, keep doing this while n is less than 1. And only once the user types in 1 or 2 or 3 or bigger will this loop finally realize, oh, n is actually greater than or equal to 1. So therefore, let's just break out of this. And then what will happen is that the number will be printed. So to be clear, let's go ahead and run positive 1. Positive 1. And again, it's demand that you give me a positive integer. No. No. Negative 3. No. So now 1, thanks for the 1. And so it actually breaks out because I've detected as much. What about positive 2.c? All right, so this introduces yet another technique. And this is where programming starts to get sort of more sophisticated still, because again, you can express yourself. So we're already moving beyond the notion of simple arithmetic and sort of underwhelming programs into the ability to sort of maintain state. That is, remember whether something happened or didn't happen. In this case, being thankful, so to speak. So it's a bit of a silly example, but this program has just this one function in main. And notice that I'm declaring another type of variable, which technically doesn't exist in C. A Boolean variable, something that's on or off, true or false, 0 or 1, doesn't technically exist in C, but we being programmers made it exist in C. We implemented it ourselves in CS50's library. In C++, in JavaScript, in PHP, in Java, in other languages, bools or Boolean variables do exist, which is why we think it reasonable just to add it backwards or retrospectively to the language. So we've defined a data type called bool in CS50.h. And to be clear, incidentally, when we say you're using a library, you're using code, a .c file that someone else wrote. But as we'll soon see when we start writing such files ourselves, the means by which you let other people use your library is to give them not necessarily the original .c file, either for performance reasons or intellectual property reasons, but you at least have to teach the programmer what functions exist, what data types exist that you created for them to use. And you do this by way of including what are called header files. So anytime you see a .h file, it's a header file, and it has sort of sketches of code, outlines of your code, so to speak, but not the actual source code per se. And this will make more sense when we see it in context before long. So this line here declares a Boolean variable, something that's got to be true or false, called thankful. And here too, you sort of see that it's kind of useful occasionally to use, it is useful to start using variables not x, y, z, but actually that describe what they are. Initialize it to false, so by default I am not thankful. And then I'm going to do the following until the user provides a positive integer. Tell them to do so with this printf statement. Then notice here too, I've sort of been a little deliberate lately, and anytime I'm getting a value and remembering it, I'm declaring a variable. But you don't have to do this per se. I could just put within the Boolean expression itself a Boolean expression, one of whose operands, this case the left-hand side, is itself a function which returns some value. So in this case, getInt, recall, is defined to just get an int from the user, and it returns it, so to speak. It forces the user to type in an int, and when it's ready, it returns it to the left-hand side, or whatever it is, whatever the context is in which it was called. So in this case, getInt is eventually, once I cooperate, going to return a number, like 1 or 2 or 3 or whatever. Then the greater than sign is going to be checked against the 0 and that value. And if whatever number was just returned is greater than 0, what's going to happen in the line below? We're going to reassign the variable thankful, not the value false, but now the value true, or the number 1. Think of it either way. So what have I forgotten, though, at this point? I've sacrificed something here with this sort of more one-line clever approach. I've forgotten the what? So I don't mean not what I've forgotten, but what have not what I've left out. Like literally, what do I no longer have any record of at this point in the program's execution? The ints that the user typed in. I don't know what it is they typed in because I didn't assign it to some variable. So if I wanted to later print it out, It's too late at that point because the user has already sort of moved on in the program's execution. So just to kind of hint at what you could do, not that this is a good thing, but these things can be nested. So if I did something like this with parentheses, I could do something slightly more sophisticated like this. And if it starts to get so clever that it's non-obvious what it's doing, and you, the programmer, or you, the TF, or you, the other programmer, has to sort of think, what is this line doing? Right? So there's a line that you eventually cross between being way clever into how few lines of code you can actually write to accomplish some task versus it just being confusing and wasting you time later to read it. But that too would work. But it would have the effect also of not only using that value, whatever the user types, but remembering it in n, if I so chose. But notice now, I'm just checking in the original version that I'm going to do the following while thankful equals equals false. And this, of course, would be a bug because it would make that statement always false. Well, let's look at the last of these versions. So in positive3.c, we have this. There's one delta between last version and this version. What have I done differently? So there's this exclamation point. So the exclamation point, as I think I may have said before, has the effect of negating some value. So that's perfect in the context of Boolean values, which can only be one thing or the other, 0 or 1, true or false, on or off. It's truly a binary relationship. If you prefix a Boolean expression or a Boolean variable with bang, an exclamation point, it reverses the meaning or the value. So what does that mean here? Well, it's just kind of more readable, at least once you get comfortable with this stuff. You're going to do the following while you're not thankful. So you could say bang thankful, but in this case it's sort of while you're not thankful. And it's equivalent functionally to thankful equals equals false. But again, it's just yet another way of expressing yourself. So that was a lot of C. And we're still this week on problem set 1, which has you working with Scratch. And so what I thought we would do is try to inspire you, albeit at my expense, with a project that was submitted last year by none other than one of this semester's new teaching fellows. So allow me to walk off stage while we play this. Starting to make sense now. It's sad. All right. If I can do this to myself, you can do homework 1 to yourself. So we'll see you on Monday.